Unit 5, Lesson 4. Okay, so recall the following from the previous lesson. The denominator of a rational function can be made equal to 0 for a particular value. That's a non-permissible value. That creates a point of discontinuity in the graph. So this is something you want to remember for, I'd say, the diploma or questions like that. This is the comprehension piece. So if you ever have something that makes 0 on the bottom, there will be some kind of discontinuity there. So that means within the graph, it'll either be the asymptote, which breaks the graph, or there'll be a hole there. Today we're talking about the hole. It's the point of discontinuity. Okay? So questions on that? Okay? Okay, so we have this right here, part 1. Consider the function. Let's look at the first investigation here. This kind of is going to explain a little bit. So state the non-permissible values for each function. They're both what? 3, right? So 3. Using graph calculator, sketch the graph on grid 1. Okay, so use the f of x. So go ahead and put that in your graph calculator right now. Let's go ahead and pull mine up too here just a second. Okay, so let's go ahead and get these put in here. So let's go clear for me. All right, so let's get this stuff put in. So x squared minus 4x plus 2 and the y1. It's important to put brackets around these guys when you're doing the trinomials. Okay, so x squared minus 4x plus 2 divided by x minus 3. Okay, so that's the first one. So we look at that one. We see the asymptote's right here at 3. Okay. My window's, yeah, not very good, looks like. Oh, yeah, really big. Let's go ahead and change that. Oops. I'm all over the place here. Okay, negative 10. There we go. Don't go by a scale of 20 anymore. All right, you guys said their standard is fine? Okay, so you still see the asymptote here is at 3, right there. Okay, good. And so then it says state the equation of the asymptote from that graph. So we state the equation of the asymptote from the graph. We have x equals 3. Oops, that's on part B, or part C, sorry. We graphed it. Part B is graphing it. Part C state it. Okay, so the student assumed the graph of y equals g of x would be similar to the graph of y equals f of x with a vertical asymptote of 3. To investigate the student's assumption of graph y equal, use your graph calculator to see what happens. So now we're going to go and put in the change. Okay, so let's put the change in. Take this off for a second. Okay, so remember you can keep this in here if you want. You can just turn it off. Just hit enter on the equal sign so it's not black and it won't graph it. Okay, so then we're going to go, the top here is x squared minus 4x. Okay, plus 3 divided by x minus 3. Okay, and we will graph that one. Now that is completely different. Looks like there's an asymptote. So, but let's look at the table real quick. There's still an error there. So this is what we're talking about. Everything is smooth except for that specific spot of 3, and now that's why it's called a point of discontinuity. Okay, so you don't have an asymptote breaking your graph up like completely. Your graph continues on, but has a hole at that location. Okay, so that's your two forms of your point of your discontinuity. Does that make sense? So, sure. Looks like a line. Okay, so as we're going through here, so it says, what shape does a graph of g of x appear to take? So it appears to be a line. Does the graph of y equals g of x have a vertical asymptote? No, it doesn't have a vertical asymptote. Like there's not a thing breaking in the graph. Explain why the graph of yg of x must have discontinuity. Because it has a 0 on the bottom. So then what gives? Like, how'd this happen? Why'd this happen? Right, there's no asymptote. There's different now. So the last lesson, that's our asymptote examples. Today's our non-asymptote discontinuity examples. So there's two forms. Okay? Questions? Okay? So the discontinuity on the graph can be seen by using the zoom decimal window. So feature the graph calculator, press zoom 4. So grid 1 is your f of x. So our f of x, we'll just sketch that again. That was at the 3, and it goes something like this. And then it goes like this. And then our y equals g of x is, let me see here, if I can figure out minus 1. Like this, and we're going to talk about the whole part. So that's what that graph looks like. So let's go ahead and go, oh shoot, I have to use the picture now. Should have drew it after. Let's go and use zoom 4 together real quick then. So I'm going to lose my picture, that's okay. All right, so zoom 4. So let's see what that does here. So we got zoom 4. Okay, so then do I hit enter? Oh, you can see it. So check it out. After I hit zoom 4, what do you see now? Yeah, you see this break. That's the hole. It just doesn't put it there. Okay? You hit zoom 4. There should be a little break in your graph now at the x equals 3 spot. Okay? Just right there. Okay. Okay, so that's what's going on. Everybody comfortable with that? Okay, all right. So we already drew that. So the break in the graph, point of discontinuity, it's called the hole. So these are two different examples of having a discontinuous graph caused by 0 on the bottom. You have your asymptote example and your hole example. What causes the hole then? So consider the functions of x plus 2, x squared plus 2x, or x squared plus 3x plus 2. State the domain of the function. The domain of the function is still going to be all real numbers except for -1. So we're looking at a second one here to try to see why this is happening. Okay. So what they want you to do on this is they want you to graph x plus 2. And then they want you to graph this guy. Okay, so why don't you guys go ahead and do that. So you're graphing x plus 2 and then this function. Pause the video while you're is that they're the same exact line, except for the second one has a hole at the -1 spot. So right about here. So it goes here and through, has a little break, a little hole there. Mine's a little bit off, but not too bad. Okay, so they're exact same lines, but one has a hole. So now we're going to investigate why that hole comes about. What causes a point of discontinuity? Okay? Because what's interesting about this is the other ones were wrapped in more like they're curved. They're curved lines, the asymptote. They cause you to have breaks in your graph. These are the lines that are just going right through, no problem, just one little spot of a problem. So why is that happening? So let's look. Okay, factor the numerator of the right side there. So if I factor the right side for b of x, it's going to factor 2, x plus 2, x plus 1. That's where the hole comes from. These cancel. So the simplified expression is just x plus 2. But, just like in Math 20, when you cancel a non-permissible, it still holds true, right? So what you're seeing is, you're seeing x plus 2, but you have to remember there's a hole at this spot of -1. That's what's going on. Okay, so that's why they showed you x plus 2. X plus 2 is the same, except for the whole. The whole comes from the canceling of these factors of negative 1. Okay, is there any questions with that? So let's determine the coordinates of the points of discontinuity by replacing the non-permissible value into the equation of the line. So you can plug in if you plug in the negative 1 into here, negative 1 plus 2 equals 1. So that means that negative 1, 1 is your whole. So what that means is that after you cancel, if you plug in what you canceled to your function, it'll tell you where your whole is at. So if you look at our graph that we just did, negative 1, 1, that's the spot of the whole. And so then we go like this, up through 2. Does that make sense? So once you simplify, you plug in what you canceled to figure out exactly where that whole is. A 0 on the bottom, so what do you mean? Oh, like there's still something on the bottom? Yeah, so then you may have that's good. That's where you're going to have a asymptote for one, but a hole at another spot. So it might come through and we'll go over that too, but there's spots on your other graph that's going to have a hole, but there still could be an asymptote. Like you can have a combination. Yeah, so what you're saying. So he asked if something cancels, you still have an X on the bottom, that means you still have a vertical asymptote. Okay? If something doesn't cancel, it's represented by a vertical asymptote. That's not going away. Okay? All right. So, good questions. Good job. Okay, so consider the function x squared minus 4x plus 3 over x minus 3 from part 1. So this is just talking about the one we started with. So g of x, so it wants me to express, okay, so we're going to factor it. X minus 3, x minus 1 is the factor at the top. So you can see why the last one we started with, that's what happened. These canceled. So then the line is x minus 1. That's why we graphed x minus 1. Okay? And so how we figure out the point of discontinuity there, what do we plug into x minus 1? What do we cancel? 3. Right? The x minus 3, so we plug in 3. So we get 3 minus 1 is 2. So the point is 3, 2 is your point of discontinuity. That's the open hole spot. Yep.
I'll ask you a question about how come on both of these, one flips and the other one doesn't, flip sides?
One flips and the other doesn't.
Like that's a -3 and then it turns to 3 and then the other one's a -1 and then it stays -1 and the one stays the same side, one flips the other side.
They shouldn't have flipped. Right. Yeah, sorry, this depends on what I'm plugging in. So I canceled an x minus 3, so that 0 is 3. Yeah. So I plug 3 in here. Yeah. Yeah. Because you're right, the x plus 1, I plugged in -1 because that makes the plus 1 0. Yeah. Okay? All right. Good. Let's get to a couple more here. All right, so then just in summary, guys, point of discontinuity is when we'll have a hole in it. When you're canceling a factor, we'll get you an open circle. Okay, so how do you figure out if you have a point of discontinuity? You factor the rational expression, simplify it by canceling common factors, substitute the non-permissible value into x to figure out where the point is. When graphing the function with a hole, your calculator doesn't pick it up the first time, so you want to zoom decimal so that it really gets zeroed in on the possible breaks. Okay, so that's zoom number 4 in your calculator. Okay, if there's multiple points of discontinuity, the calculator may not show them all, especially in multiple of the zoom decimal window, because what it does, it zeroes on one at a time. So you may have to kind of adjust and actually just know what you're doing in terms of graphing, not fully rely on your calculator is kind of the short answer there. Okay, so let's look at this guy. So this is where we kind of tie in, guys, our unit 4 stuff, our polynomial stuff a little bit. So consider the rational function of x cubed minus 7x plus 6. Write the numerator of the function as a product of 3 binomial factors. So we need to factor the x cubed here. Okay, so how can we do that? Well, first off, what's the one we're interested in? X minus 1. Synthetically divide 1. 1. Don't forget the 0 for x squared. So we're going to synthetically divide that to see if the bottom is the factor of the top. It might not be, but in this case we're hoping because we're doing wholes. So 1, 1, 1, 1, negative 6, negative 6, 0. It is. Okay? So that means one of the factors of this guy is x minus 1. What do we do now? How do we keep going? Right, we take the quotient and we try to factor that. So it's going to be x squared plus x minus 6, right? And that does factor to what? X plus 3, x minus 2. Good. So now we factor the top. So you think that's really hard? Okay, it wasn't too bad. And so here's where we're at. Okay. Okay, so right to numerator is a function of product of 3 binomial factors. So we did that. So let's write this right here. So the 3 binomial factors are and x minus 2. That's the top factored. Determine the coordinate of the point of discontinuity. So how do I figure out the coordinate of the point? I cancel and plug in 1 to here. Okay, so it's going to be 1 plus 3 times 1 minus 2. So it's going to be negative 4. So your point is going to be 1, negative 4 is your point of discontinuity. Okay, any questions? So let's just talk about this before I come down to the graph and just get the kind of understanding going here. So we understand this is going to cancel, right? So what's left? So what kind of graph is this? Parabola. It's a quadratic now. So it's not a line. They're not all going to be lines. It's a quadratic. So it's going to be a parabola with a hole on it. That's what's left. I'm going to have a parabola with a hole at 1. Does that make sense? Okay, so let's draw it. So that parabola has the zeros of negative 3 and 2. Okay. We'll skip the graph calculator part for this one. But negative 3 and 2. So we're at negative 3 and 2. And then we know our point of discontinuity is at 1, negative 4, right? So then here's your graph. That goes straight through. And your hole is right there. You can label like that y-intercept should be what? That y-intercept should be negative 6. So this should be 4, 5, negative 6. That's pretty good there, actually. Okay. Any questions on that? They're okay? All right, then. We're on the last page here. All right, let's do one last example here. Okay, so the graph of the rational function is a straight line with 2 points of discontinuity, so it tells you what to expect. So if it's a straight line, what's that mean to us? Two things are going to cancel, because this is why. Another reason, okay, hold on. I need to slow down. Why is that a straight line, just looking at it? Can you tell? Okay, good. Yeah, you're by how much? Degree of 1. So that's a cube, that's a square, right? Those are 1 apart. So when I take those apart, I'm going to be left with a degree of 1. A degree of 1 is a line. The one we just did was a cube over an x, right? A degree of 3 and a 1. So what's the separation? We had a parabola because the separation was a degree of 2, right? So that's why looking at this, we can kind of think about it might be a line if things factor nicely. So they give you the hard, not the hard, but the thing we have to do here, we have to do decomp on the bottom, figure out what that factor is, and then we're going to have to go ahead and synthetically divide them out to make sure they are factors. They're telling us they are. Okay, they're saying you have 2 points of discontinuity. Okay, but let's go ahead and do that. 2 times 5 is 10. Factors of 10 that get you 7 is that 5 and 2. I'm just factoring the bottom right now, so I know what to synthetically divide. Okay, so 2x squared plus 2x plus 5x plus 5. So we take out a 2x, x plus 1, take out a 5, x plus 1. So we get our factors that we're going to look at is 2x plus 5 and x plus 1. So those are the two zeros from the bottom that I'm going to synthetically divide. Okay, those are my points of discontinuity, or excuse me, those are my discontinuous spots. We're assuming they're points of discontinuity because they said they would be. Okay, so we're going to try negative 5 halves and negative 1. Let's just do the negative 1 first, since it's easier, and that's just less factors. So if we go negative 1 here, 2, 1, negative 16, and negative 15. So drop the 2, negative 2, negative 1, 1, negative 15, 15, 0. Okay, so that is a factor of the top. So if I'm coming over here and I'm writing this, the factor on the top, x plus 1 is 1. Okay. Second thing, now I have to do it to this. So it's going to be negative 5 halves. Yep.
Can we do 2x squared minus x minus 15 and factor?
You could factor it. Okay, you could factor it. So yeah, it's up to you. I guess what do you guys want? You could factor it, or you can do, because they're telling us we're going to have 2 points, so I kind of know that should be a factor. So it's really up to you. If you want to factor it, and then you should get 2x plus 5, or even I guess you can intuitively say, if this is 2x squared minus x minus 15, if I know 2x plus 5 should be a factor, what's the other piece have to be? So 2x times what is 2x squared? X. 15 times, how do I get to negative 15 from 5? Negative 3. So I mean, you could do that. All that stuff's fine. Okay. Yeah, the notes just went ahead and factored it too. So I mean, you can do either way. You can do synthetic again, you can factor, or you can do what we did there. We piece it together with what we expect. Okay. Does anybody want to see any of those? Are we okay with factoring in synthetic? You guys okay? Okay. So that means that it's going to be here, here, and then here. So then what we're going to do now is we see that these cancel. So we're going to test negative 1 into x minus 3. And we're going to test negative 5 halves into x minus 3 to get my 2 points of discontinuity. So I'm taking my things I canceled. I'm plugging them into what's left. So negative 1 minus 3 is negative 4. So that means that negative 1, negative 4 is a point discontinuity. We're doing part B on the bottom here. Okay, and then negative 5 halves minus 3, that's going to be negative 11 halves. So it's going to be negative 5 halves, negative 11 halves as a point of discontinuity. So there's my 2 holes. Okay. Any questions before we just go down there and graph it real quick? Because now we just got to graph the line of x minus 3, and just graph that full line, right? And just go erase those spots. That's all you have to do. Okay, so graph that x minus 3 line, go erase at those 2 points. Okay, so let's do that. Okay, so the rough sketch here. So x minus 3. All right, so we got x minus 3, so we'll start a little bit lower here. 1, 2, 3, 1, 2, 3. So this is what the line looks like. Okay, and our points of discontinuity was negative 1, negative 4. So my first one that I'm going to erase here is going to be like right about here. Negative 1, negative 4. And then negative 5 halves is negative 2.5. So negative 2.5, negative 11.5 is 6.5. So I'd say that that's right about there. So there's my 2 holes. Well, that's a little bit off. But you just draw your 2 holes in now. Okay. All right. That's everything.